Hello, this is Ira. So today we're gonna go over valves 181001. We're gonna review knowledge 6, and in knowledge 6 we're gonna take a look specifically to the MOV operation and a little bit about gate valve. Okay, so let's get started. So in the MOV operation we have something that we call the clutch lever, which help us engage the hand wheel and it disengage the motor. So the clutch or a lever, it's allow us to manually the clutch and will help us engage the hand wheel when the motor is not engaged, and that's something really important. The motor needs to be not engaged, right? Otherwise we can damage this. Also, if we want to move the lever or this lever or the clutch from this normal position, we need to do this. We need to disengage the motor first, right? Step one. And that will allow us to engage the hand wheel and be able to move it. If we attempt to manually engage the hand wheel while the MOV is moving, we will likely damage the clutch, right? So we don't want to do that. So if the clutch lever has been operated and released, and the operator is manually operating the valve, the hand wheel will disengage and it will respond to the electrical signal from the motor instead. So that's what's gonna happen. And basically that's all that we need to know for this section on the clutch lever. And also for MOV operation, we have the valve actuator motor. The valve actuator motor is re-engaged by energizing the valve actuator motor, and we will take a look at some of the examples. But here we have the valve actuator motor is re-engaged by energizing the valve actuator motor, right? And as I said, we will look at a couple examples of that. And then we have the gate valve. The gate valve, for this knowledge, the only thing that we need to know is that the gate valve requires the most manual valve stem rotation to move from fully open to fully closed. So if we want to move from fully open to fully closed, it's going to require the most stem rotation movement. And as we can see it in here. Okay, so now let's jump into the examples that we talk about. So we have a typical motor operated valve with a clutch lever, and the clutch lever is installed in an emergency core cooling system application. The EEC actuation signal is designed, so this signal is designed, and this is important, to energize the valve motor and open the valve. The valve is currently open, but being manually locally closed by a technician as required by a surveillance test procedure. The declutch level has been operated and released, and the valve is being closed by operation of the valve hand wheel. If the ECCS actuation signal is received, how will this affect the valve? So that means that we are re-engaging, right? We are re-engaging the actuator motor. So what's going to happen? If we are if we were manually operating and then we re-engage again, that means that we are disengaging the hand wheel. That's something that we are doing. The hand wheel is disengaged because we are engaging, re-engaging, or re-energizing. As we can see here, we are re-engaging the valve actuator motor by energizing the valve actuator motor. So that means that the hand wheel will disengage. We are not using the hand wheel anymore, and the valve will automatically open. And why will automatically open? Because it was designed to energize the valve motor and open the valve, because that's how it was designed. And some of this in here we can see kind of like it's giving us the answer. The next one. A surveillance test procedure is being performed in a typical MOV with a declutch lever that is used in an emergency core cooling system ECCS application. The declutch lever has been operated and released, and the valve is manually locally opened by a technician. The MOV breaker is closed as required by the surveillance test procedure. During operation of the valve handwheel, an ECCS actuation signal is received that normally energizes the valve motor and closes the valve. So that's what it usually happens. It energizes the valve motor and closes the valve. How will the valve be affected by the actuation signal? So we know if we are re-engaging the valve actuator motor, we are disengaging the hand wheel. So we know that we are disengaging the hand wheel. So we have these two answers, A or B. But here it's telling me that normally when this energizes the valve motor, it's going to close the valve. So that means that the hand wheel will disengage and the valve will automatically close. So that's going to be my answer. And the last example, a typical MOV has just been opened from the main control and the breaker for the MOV has been opened. A plant operator has been directed to close the MOV locally for a surveillance test. If the operator attempts to turn the MOV handwheel in the clockwise direction without first operating the declutch lever, which one of the following will occur? So if we have this MOV, right? It says that the breaker has been opened, right? So the breaker has been opened. That means that the valve motor actuator is functional, right? So we are energized. So if we energize, and if we try to move the hand wheel, what's going to happen? So the hand wheel, in this case, it will turn. It will be able to turn. We will be able to turn the hand wheel, right? We'll still be able to move it, but the stem will not move, right? Because we are energized. So the stem, which is, right, to drive this part, it won't move. So we won't be able to do anything, right? Because we disengage the hand wheel. So the answer is A, the hand wheel will turn, but the valve stem will not move. And that is all for knowledge 6. Thank you.